Hi friends, welcome to Talent Sprint's Banker's Choice program. In this session, we are going to discuss the most interesting and the most important topic from logical reasoning, that is syllogisms. Syllogism means inference or deduction, where a set of statements and a set of conclusions are given to us. We are supposed to assume the given statements to be true even if they vary from the commonly known facts, and then find out which of the given conclusions follow the given statements. So we can say that syllogisms is nothing but a logical argument where we are supposed to check whether the given conclusions follow the given statements or not. Let us now take an example to understand how does a question from syllogism look like. As I've already mentioned, in syllogisms, a set of statements and a set of conclusions is given to us, and we are supposed to decide which of the conclusions are true with respect to the given statements. Let us look at the given statements here. The statements are all cats are bats, and the second statement is all bats are tables. So as you can see here, there are two statements. The first statement is all cats are bats, and the second statement is all bats are tables. As I've already told you, the statements may vary from the commonly known facts. For example, in real life, there is no relationship between a cat and a bat. And similarly, there is no relationship between a bat and a table. But the statement says all cats are bats and all bats are tables. So though they seem to be completely varying from the commonly known facts, we have to assume that the given statements are true. So remember friends, whatever the statement is given, it has to be assumed to be true, even if it varies completely from the commonly known facts. Now, the given conclusions are some tables are bats, and the second conclusion is no cat is a table. So we are now supposed to check which of these two conclusions follow with respect to the given statements. So by assuming that the given statements are true, we have to find out which of these conclusions are true. To solve questions from syllogisms, the best method is to use Venn diagrams, where we draw the statements in terms of Venn diagrams or nothing but Euler's circles, and then check which of the conclusions are true. But before we understand how to draw Venn diagrams, let us first understand what are the various types of statements and quantifiers used in case of syllogisms. As you can see in the given statements, we have different quantifiers like all, some, no, etc. So let us first understand what are the different types of quantifiers we use. A quantifier is essentially used to express the quantity of a given set. So the different types of quantifiers that we have are all, no, some, every, few, etc. And these quantifiers can be basically classified into three types. The first one here is all, or it can also be referred as every. All or every. The second one is no or none. And the third one can be taken as some, or it is also referred to few sometimes. So these are the three different types of quantifiers that we use: all or every, no or none, some or few. Now whenever we use the term all, it refers to all the objects in the given set. Similarly, whenever we use the term no, it again refers to all the objects of the given set. For example, when we say all A's are B's, it means all the A's are B's. So each and every A in the set is B. Similarly, when we say no A is B or none of the A's are B's, it means each and every of the element in the set A is not a part of set B. So these two quantifiers, all or no, are referred as universal quantifiers because they refer to each and every object of the given set. The third type of quantifier that we have is some or few. For example, when we say some A's are B's, it means some of the elements in the set A are a part of the set B. Similarly, when we say some A's are not B's, that means some of the elements in set A are not a part of set B. So in these two cases, you can see that we are not referring to every object in the given set. So the quantifier some or few refers to a certain number of objects in the given set, and it is generally referred as a particular quantifier. Right? So we have two types of quantifiers in general: universal quantifier or particular quantifiers. All and no comes under universal quantifier as it refers to every object of the given set, and some or few comes under particular quantifier as it refers to only a particular number of objects in the given set. The other important point which we need to understand about quantifiers is the range of the quantifier sum. For example, sum generally means at least one. When we use the term sum, it refers to at least one. For example, when we say some A's are B's, it means at least one A is B. So minimum one A has to be B for this statement to be true, and maximum all the A's can be B. So from this we can understand that when we say sum, it can mean only one, and it can also mean all, as the minimum for sum is to be 1 and the maximum can be all. So very clearly, when we say some A's are B's, it may mean that one A is B or all the A's are B's. So you just remember that sum can be referred as 1 and also it can be taken as all. Let us now take the different types of statements that are used with the help of these quantifiers.